Okay, so we come round, we query the address space of the process we want, our address, which we start as 0. That will return us a block, which we can use to create our own memblock structure and add it to the linked list, and then we update our address variable to the address that we've just got back from this plus its size, i.e. we move our search point onto the end of this block, so the next time round it will return the address above the block that we've just found, and eventually we'll hit the last block, we'll find that, and then this call will then return 0, and then it's time to break out. So that's our basic function to scan through and find information about the memory layout, but there's a couple of useful optimizations we should do here. This meminfo structure gets returned for any kind of memory that this process has used or is intending to use, so it will return things that are not writable, which we don't care about, and it will also return things that haven't yet been committed. What that means is in Windows you can reserve some memory space without actually committing it for reading and writing, so it won't exist in any meaningful form, but it will have just been reserved and this thing will pick it up. So what we need to do is filter out those ones that we're not interested in. So first of all, we check the member called state and we look for the mem commit flag. And what that means is we discard any blocks that don't have the committed flag set in the state, which means that they do actually exist for real and haven't just been reserved for later use. So let's move all that into the if statement, and the other thing we can do is check that it has the right permissions set on it, because we're not interested in read-only pages because they can't possibly hold anything we'd be interested in. And there's 4 flags that we need to check for that all in some way mark it as writable, and they are page read write and page write copy, and then the same but with the execute permission as well, so page execute read write and page execute write copy. So we will just make a quick define which will hold all those. So all we're doing there is just masking together all the different flags so we can check for them in one go. And these are held in the member called protect, and we can now just mask it with this that we created here. So if any of these flag bits are set, this will be picked up here. So now what we've done is we're still looking at every single block that gets returned by this, and we're filtering out any that don't have the commit flag set and don't have the writable permissions set. So now that we've got our create scan, again we need a corresponding free scan. Which will take a linked list, and all we need to do is iterate through the linked list and close each interval or free each individual mem block. But first we should close the process handle that we opened up here, and then we just have a loop that will loop through until we hit the end of the linked list, at which point MB list will be null. So let's get a temporary memory block pointer, move the head of the linked list on, free the block that we've just pulled out of the linked list. So this will loop round, freeing each block in turn until MBList is null, at which point we've reached the end. To test what we've got so far, we'll make a quick function called dump scan info, which will take our linked list, and this will just print out the information about every block that we've found. So we need a local pointer at the head of the list and loop through until the list is finished, and we'll just print out the address in hex and the size in decimal. Like that, and move the local pointer onto the next item in the linked list, and then we'll just quickly make a main function and we'll make ourselves a scan by calling create scan, just using a command line argument that got passed in. And if we manage to create one, we will dump it out and then free it. So let's try compiling and running what we have so far using Cygwin again. Okay, that compiled alright, so I need a process ID to test with. So I can just run task list, that's a list of all the processes running, and just use Notepad because that's nice and simple, 4272. So if I now run with 4272, and you can see that that's the memory layout that it's found for the Notepad process. So these are the various blocks and the addresses in the Notepad process that they exist at. So that's the first stage working successfully, using Virtual Query X to find the memory layout of a process. What we're not doing currently is actually reading the memory anywhere. We're just finding which blocks in memory are valid and which aren't. So what we need to do now is create a function that will actually read the contents of memory into the buffers that we've already allocated. So let's put it here and we'll call it update block, or update mem block is better, and it will take a pointer to one memory block. Now let's declare some variables. We're going to use a local buffer called tempBuff excuse me, tempBuff, and let's call it 128k's worth. So we'll read in blocks of 128k, and we'll also make some variables to take care of the read. So we need a total, and we'll see how these get used now. So bytes left is how many there are still to read. So it starts off as the size of the block, and the total read starts as 0. So while there are still bytes left to read,